Everything around us is in a constant state of flux. Think about your day. The temperature outside changes. Cool morning, warm afternoon. Your height has changed since you were a baby. It might even change a tiny bit during the day. A car driving down the street is changing its position every single second. This idea of change is one of the most fundamental concepts in our world. We see it. We feel it. We experience it from moment to moment. It is the difference between what is happening now and what was happening a little while ago. Understanding change is not just interesting, it is also incredibly useful for making sense of the world. To talk about change in a more precise way, we often ask, how fast is something changing? Is the car moving slowly or quickly? Is the plant growing at a steady pace or suddenly sprouting up? Is the sun setting rapidly or does it seem to hang in the sky? This question of how fast is the key that unlocks a very powerful area of mathematics. It moves us from simply noticing differences to measuring the rate at which they occur. This measurement gives us the ability to predict, to analyze, to understand. These dynamics appear everywhere: the economy, the weather. In mathematics, we have a special tool to measure how fast things change at a single exact moment. This incredible tool is called the derivative. It might sound complicated or intimidating, but the idea is simple and intuitive. The derivative finds the rate of change at one specific instant in time. It's like a magical speedometer. Not your speed over a whole hour, but your precise speed at the exact moment you look. Let's begin with a very simple idea that you are already familiar with: the average rate of change. This is something we calculate all the time, even if we don't use these exact words. For example, if you go on a road trip and you travel a total of 200 kilometers, in 4 hours you can easily figure out your average speed. You simply take the total distance you traveled and divide it by the total time it took. In this case, 200 kilometers divided by 4 hours gives you an average speed of 50 kilometers per hour. This single number summarizes your entire journey. This calculation gives you an average because it doesn't tell you your speed at any specific moment during the trip. You probably didn't drive at exactly 50 kilometers per hour for the entire 4 hours. Sometimes you might have been going faster on an open highway, maybe at 70 kilometers per hour. At other times, you might have been stuck in traffic moving at only 10 kilometers per hour, or even stopped completely. The average rate of change smooths out all of these variations and gives you a single representative number for the whole interval of time. It is a good starting point for understanding motion and change. We can generalize this idea beyond